Good afternoon, everybody. Thank you for the introduction, Wendy. I'm from the Black Rhino Range Expansion Project, but up until a year and a half ago, I actually lived and worked on Symposium Game Reserve, where I started research into tick-borne disease transmission between wildlife and livestock back in 2005. And this research here is a little bit of an add-on or a result of some of the earlier results that I found from a couple of years ago. So first of all, one thing that's going to come up time and time again, and I was actually also quite excited to hear Wendy talk about a lot of the concepts that are going to come back in this presentation as well, even though we are dealing with a single site and a single game reserve, is that ticks respond to climatic variables, both temperature and rainfall, and that also very much determines their distribution. So climatic events are very important when it comes to ticks' responses to extreme weather events, and how they respond, and also what sort of effects this has on the tick's hosts, especially in case of wildlife. Very often, especially in drought situations, the tick's hosts will end up suffering with those extreme weather responses that the ticks give, and often also this increases the likelihood of a disease outbreak. As you can see on the side there, I've got two tick species which I will be speaking about. The first one is a bond tick, which is very often found on rhinoceros, and the same goes for the brown ear tick at the bottom. Brown ear tick is also responsible for transmitting corridor disease, which is a very economically destructive disease, mostly affecting cattle. Bond ticks as well, they can carry heart-water disease, which is also very detrimental to the livestock industry. So to give you a bit of a recap of what I had studied in the past 2 years in terms of tick-borne disease transmission between livestock and wildlife on Samkanda, and how this has led me to looking at rhinoceros in particular, and the drought that we've recently gone through in Zululand. So with the extreme drought, I actually ended up doing this research sort of by accident. It happened to carry into this extreme drought, and we actually found some very interesting drought anomalies that carry through. So one thing that you can see here is if you look at the rainfall graph here, which is graphed here on the secondary axis, and if you look at the brown ear tick and the bond tick, between about June 2015 and February 2016, we recorded absolutely no brown ear ticks in livestock or in wildlife. And that is quite unusual, because usually the brown ear ticks, they will go into a sort of hibernating state as nymphs for a couple of months in spring, which would be normal. But essentially this diapause, which is this hibernation stage, extended for 6 months through the drought. So the brown ear ticks just didn't go into the adult phase. Then you can see there was a once-off extreme rainfall event, which almost dumped 100 millimeters of rain onto the reserve. And this caused the response of the brown-eared adult ticks showing up in our samples a couple of months later. So based on that, I wanted to know, well, what's happening after this, as knowing that rain has fallen again now in 2016, 2017, as Ian alluded to. And what's happening here? How is this picture carrying on? And so the question is, why look at rhinos? Well, actually what we found was something that has never been found before, at least in South Africa. And I actually found adult brown ear ticks in rhino samples when we had taken them after that rainfall spike during that extreme drought. So the rainfall spike came in about December 2015. And in December 2015, and by June 2016, I started finding adult brown ear ticks in rhino samples. When I first submitted those samples to the Veterinary Institute to get identified, they actually thought they had misidentified those ticks, and I had to go back later on, and they confirmed that it was actually brown ear ticks, which just hasn't happened before. Also, in terms of the research, rhinos are relatively easy to sample during immobilization events. They are down on the ground for a number of minutes, and it gives you a chance to go and sample. And also the sampling can be done over the same period every year, and which is in autumn and in winter during the cooler months. And it also coincides in Zululand after the rainfall period, which works quite nicely since we are looking at rainfall here. and tick abundance. So the aim for this one, for this research, was to look at 3 specific questions. The first one is, what happens to tick species and numbers that are associated with rhinos as hosts during this drought period and also after the rains? So what happened after the drought? And also what started to come out a little bit as I was looking at the data is there a difference in tick prevalence and load between black and white rhinos? So just a quick recap. So the study site was Symposium Game Reserve, and I collected ticks between April 2015 and July 2017. The game reserve has a good population of black and white rhino, but one thing that has to be noted as well is that African buffalo were introduced in May 2016 to the reserve. African buffalo are actually one of the main hosts for brown-eared tick, adult brown-eared ticks. So before May 2016, that's quite important host that makes up a majority of hosts for brown-eared ticks was actually absent in Samkanda. And that is something that will come in later as we look at the results. A quick run through the methods. So as I mentioned before, we used immobilization events where rhino were dehorned and collared to collect the ticks. Obviously, it wasn't possible to fully detick a rhino in a short period of time that the rhino is down. So in order to have a good measure of reference and collect during the collection, we did 5 minutes in the front, so the head, and then 5 minutes in the back of the rhino, and just to try and standardize the collection a little bit. Ticks were stored in 70% ethanol, and they were submitted to the Veterinary Institute in Pretoria to be identified down to species level. Okay, so to have a look a bit at the results here, so the 2 main tick species that we found on rhino is a bond tick and Rhiphicephalus maculatus, and obviously in the brown-eared tick as well, which was the anomaly. So as you can see in the graph, I've graphed rainfall there again, and you can see that by about October, November 2016, the rains actually came, and yeah, so unfortunately I wasn't able to collect much data in that period there in 2016, but that gives you a bit of an idea of what we found. So with Rhiphicephalus maculatus, it's actually, it belongs to the same genus as the brown-eared tick. Brown-eared tick is also Rhiphicephalus, but maculatus doesn't carry any known diseases of economic importance. However, maculatus is actually a very good indicator species in ticks when it comes to climatic variables, and they actually respond and shift quite quickly. So what you can see, for example, is during the drought period, and we had this spike of this intense rainfall event, maculatus responded, the adults responded to that, so the nymphs would have come out, and within 2 months we recorded a huge amount of maculatus on rhinos. You can see a similar response, but not quite as severe after the drought broke in early 2017. And then again, you can see here in the little red bars there, that's the anomaly. Those are the brown-eared ticks that we found during the height of the drought, mostly in white rhino, but a few in black rhino as well. Bond ticks seem to be fairly stable through this period, both through the droughts. You can see a little bit of a spike there in June 2017, but they seem to be a little bit more stable. One of the most important things that we see here, and it's sort of, you breathe a bit of a sigh of relief, is that in 2017, now in April, May, June, we actually didn't find brown-eared ticks in the rhino samples anymore, which is quite a good thing considering that brown-eared ticks carry corridor disease. So you can see that that those guys have disappeared. But why? Or what could the causes be besides having rainfall? And the interesting thing is that in May, June 2016, the buffalo were introduced. So now all of a sudden, on Samkanda, there are buffalo, which is one of the main hosts for adult brown-eared ticks, and we've got an increase in rainfall. So the best speculation, or the best scientific guesstimate that I have, is that that's a nice little spike there, in rainfall, it caused the brown-eared ticks to come out. Now, you already had drought-stressed animals. We didn't have buffalo on the reserve. And these brown-eared ticks, we had a spike in the population. They came out, and they had essentially nowhere to go. So they found rhinos as hosts, which is, as I said, very unusual. And that could also be the reason why they didn't actually show up again in 2017, because now the reserve had, I believe, about 70 plus buffalo. And of course, the drought has broken as well. So looking at black rhino and white rhino, you can actually see that there is quite a significant difference when it comes to tick loads and distribution between the two species. Interestingly enough, Rhiphicephalus maculatus seems to be represented very strongly before that severe drought year and after that severe drought year. And even the bond ticks, we found a significant amount on black rhino, but definitely not as many as on white rhino, which is quite interesting. You can also see the two little red bars. There's one in June 2015, and then there's one in June 2016. Those are the brown ear ticks we found on black rhino. But if you look at white rhino and you look at the bar there in April, June 2016, we actually found a lot more brown ear ticks on white rhino than we did on black rhino. Okay, so what does all of this mean, and what can we learn from this? One of the things that has definitely stood out with this is that short but intense rainfall events within a drought or a super drought period can actually trigger tick population spikes. And that's then what leads on to anomalies, such as the appearance of adult brown ear ticks on rhino. Now, of course, as I mentioned before, there is the implication of the absence of a suitable host, i.e. buffalo, which were not there. But still, it's an interesting response of the brown ear tick, considering the unique situation that the reserve was in at the time, and getting that one-off spike in rainfall. Another thing that is probably very nice to hear for anybody working in black rhino conservation is that it seems that black rhino actually have a lower tick load and seem to do quite well during drought periods. And especially during a drought period, that can have a positive effect on maintaining body condition. And we actually see that quite a bit in the black rhino range expansion project. Also going through to the droughts in some of our sites in Limpopo is that the black rhino were actually able to keep their body condition very well. The big sigh of relief at the end of the day is that post-drought, it actually appears that the tick loads and the prevalence and everything goes back to pre-drought levels, which is great. So it means we don't have to worry about brown ear ticks on rhino if we start moving them around now. But what does it mean for wildlife management, and what does it mean for long-term and for the future? Obviously, the ticks' responses to the droughts can trigger disease outbreaks, and that can happen through a variety of ways. An increase in overall tick populations if the conditions are right. For example, if you have these one-off spikes in rainfall during a huge drought period, that triggers the adult ticks to come out. And if they do carry disease, then that gets spread quite easily. Also because you're dealing with drought-stressed animals at that point, which means that the diseases are able to spread even quicker. And of course, you also have those abnormal tick responses, such as those adult brown ear ticks that we found on rhino. So if you're moving animals in a drought period, it actually can become an issue, especially if these abnormalities occur, not just with what we know now about brown ear ticks, and what was most likely a very unique and special event, considering that Samkanda didn't have buffalo, and we dealt with a drought event, and we dealt with that spike in rainfall in December. But still, these small events, they do happen, and it is a result of climate change and of shifting climate. So the take-home message is that with climate change, these events might actually become more frequent, and we might see these abnormal tick responses or other abnormalities more often. They may not become the norm, but they may actually show up more often. And that is a concern in terms of disease prevention, and also for anybody working with wildlife and managing wildlife and trying to manage a reserve. And this especially also comes in light from one of the papers that Olwok wrote in 2007, where it has already been shown that climate change is influencing the range expansion in ticks of the genus Rhiphicephalus, which includes maculatus and which includes the brown ear tick, where they've seen that 70% of the genus Rhiphicephalus species, tick species, are actually expanding their range due to climate change. And that's mostly due to an increase in temperature. So yeah, the take-home message at the end of the day is that this is this was a small reserve on it's a single site, but looking at the responses of ticks and how it can affect its hosts, it actually does beg the question: what is climate change going to bring, and what are these extreme weather events going to bring, and how can wildlife managers how are they able, or how can they keep their wildlife going, and how can they manage their reserves as effective as possible, keeping these sorts of weather events and climatic events in mind. And then I just want to say thank you to Dave Gilroy and the Samkanda Reserve team. They've been fantastic. I've been able to go back to the reserve, even though I no longer live there, unfortunately. They've been very helpful. Also, thanks to Taryn. She did a bit of tick collection for me as well in my absence. And of course, the Black Rhino Range expansion project that I work with now. Thanks.